Welcome back to Lesson 4 in our study of the application layer of networks and distributed systems. Based on a textbook by Jim Carouse and Keith Ross, Computer Networking, a Top-Down Approach. Let's move on. In many Internet applications, the client and the server communicate for an extended period of time, with the client making a series of requests and the server responding to each of the requests. Each request/response pair can be sent over a separate TCP connection called non-persistent, or the requests and their corresponding responses can be sent over the same TCP connection, persistent. You can see the characteristics of a typical non-persistent connection over the next couple of slides. As the browser receives the web page, it displays the page to the user. Two different browsers may interpret a web page in different ways. HTTP has nothing to do with how a web page is interpreted by a client. That's why it's not a bad idea to have more than one web browser available. Google Chrome, Firefox, Microsoft Edge, etc. are all fine web browsers. Occasionally, any browser may not interpret the page correctly. Also, the different browsers may claim better performance than their competition. One way to evaluate that is by the round-trip time, which is the time it takes for a small packet to travel from client to server and then back to the client. The round-trip time includes packet propagation delays, packet queuing delays in intermediate routers and switches, and packet processing delays. Non-persistent connections have some shortcomings. First, a brand new connection must be established and maintained for each requested object. For each of these connections, TCP buffers must be allocated and the TCP variables must be kept in both the client and the server. This can place a significant burden on the web server, which may be serving requests from hundreds of different clients simultaneously. Second, each object suffers a delivery delay of the two round-trip times, one round-trip time to establish the TCP connection and one to request and receive an object. With persistent connections, the server leaves the TCP connection open after sending a response. Subsequent requests and responses between the same client and server can be sent over the same connection. An entire web page can be sent over a single persistent TCP connection. Moreover, multiple web pages residing on the same server can be sent from the server to the client over a single persistent TCP connection. These requests for objects can be made back-to-back without waiting for replies to pending requests. This is called pipelining. Typically, the HTTP server closes a connection when it isn't used for a certain time. When a server receives the back-to-back request, it sends the objects back-to-back. The default mode of HTTP uses persistent connections with pipelining. HTTP specifications include the definition of HTTP message formats. There are two types of HTTP messages, request messages and response messages. Here you see a sample request message. The message is written in ordinary ASCII text so you and I can read it. The first line of an HTTP request message is called the request line, and the subsequent lines are called the header lines. The request line has three fields: the method field, the URL field, and the HTTP version field. In object-oriented programming, a method is a programmed procedure. A method in an object can only have access to the data known to that object, which ensures data integrity among the set of objects in an application. A method can be reused in multiple objects. The method field can take on several different values, including get, post, head, put, and delete. The great majority of HTTP request messages use the get method. The get method is used when the browser requests an object with the requested object identified in the URL field. Look at the general format here of a request message. Notice after the header lines and the additional carriage return and the line feed, there is an entity body. The entity body is empty with the get method, but is used with the post method. An HTTP client often uses the post method when the user fills out a form or provides search words to a search engine. With the post message, the user is still requesting a web page from the server, but the specific contents of the web page depend on what the user enters into the form fields. HTML forms often use the get method and include the inputted data in the requested URL instead of the form fields. By the way, everyone should be aware that what is actually contained in all these fields is a binary code, a bunch of zeros and ones. Here you see a little of the evolution of HTTP. The response message has 3 sections: an initial status line, 6 header lines, and then the entity body. The entity body contains the requested object itself. The status line has 3 fields: the protocol version, the status code, and the corresponding status message. In this example, the status line indicates that the server is using HTTP/1.1 and that everything is okay, meaning the server has found and is sending the requested object. This slide shows you some status codes on a response message. If you have the Telnet utility on your computer, you can give this script a try. Remember that Telnet messages, including passwords, are transmitted in clear text. Many users prefer using the SSH protocol instead of the Telnet protocol because the communication is encrypted. As we learned earlier, HTTP server is stateless. This simplifies server design and has permitted engineers to develop high-performance web servers that can handle thousands of simultaneous TCP connections. However, it is often desirable for a website to identify users, either because the server wishes to restrict their user access or because it wants to serve content as a function of the user's identity. For these purposes, HTTP uses cookies. You're probably familiar with cookies. Cookies allow sites to keep track of their users. Most commercial websites use cookies. In this slide, we see the 4 components of cookies: a cookie header line in the HTTP response message, a cookie header line in the HTTP request message, a cookie file kept on the user's end system and managed by the user's browser, and back-end database at the website. Note that in the 3rd component, the user's system manages the cookie file, which means the user can clear it or let it stand. Well, that was a challenging lesson. Let's take a break and review our notes and our study guide and take care of any assignments that we may have, and then come on back. We'll start lesson 5.